Water is necessary for life. But often, we don't have water where we need it, or there's too much, or it's not safe. So, we overcome those challenges through infrastructure. But having effective infrastructure comes with challenges of its own. We need to be able to deliver projects in a way that addresses the complex technical aspects of engineering to balance social, environmental, and financial concerns. And once that infrastructure is built, we need to make sure those assets perform effectively to serve their intended purpose. Bentley continues to be at the forefront of infrastructure engineering software, empowering water professionals to do their work more effectively through the adoption of intelligent digital twin solutions, positively impacting billions of people throughout the world. Of course, much of the Earth's water isn't managed through what we typically think of as infrastructure, such as groundwater and river networks. But the ability to understand those systems and our interactions with them is still critical. The ability to forecast and visualize flooding is an important tool both for design of flood control system and emergency response during flooding events. Dams are important for flood control and water supply. Monitoring their condition and performance is critical, but traditional manual methods can be dangerous and expensive. That can be greatly minimized using technology like drone imagery and AI to identify and categorize defects, as well as comparing them over time to track their progression and the effect of remediation efforts. Connecting sensor technology provides visibility into the current and historic performance of the dam to support operation and maintenance decisions. Monitoring is also a challenge for the complex underground piping networks that distribute drinking water throughout a city. Our digital twins combine information from traditionally siloed technologies that include GIS, SCADA, and simulation tools to gain insights that no one system can do by itself. This gives operators the ability to understand the performance of their networks, not only ensuring adequate pressures and water quality, but also tracking efforts to improve energy efficiency and reduce water loss. AI can also help identify problems and alert operators when the system begins behaving abnormally. And decision support allows the utility to determine a well-informed response, which reduces the impact on customers. Of course, operators can only work with the assets that they currently have. Engineers need to ensure the long-term resilience of the system by making good planning and design decisions, like identifying critical elements and reducing the impact of potential failure. Engineers can forecast how the system will change over time and evaluate that against a range of possible future demands as the city grows and evolves. They can make risk-based decisions for capital planning and better pump selection to reduce costs due to energy efficiencies, as well as improving the utility's carbon footprint. Engineers can even reduce leakage by configuring zones to manage excess pressures more responsibly. Similar to the challenges for water distribution, sanitary sewers and storm drainage also involve vast networks of infrastructure, much of which is below ground. Engineers can understand the root causes of problems in those systems, as well as recognizing the impact when the system is above capacity. With hydraulic analysis tools, they can see where and when overflows occur so they can mitigate them. Engineers can apply low-impact development techniques to divert stormwater runoff or underground storage to contain excess flows without overwhelming the network. Advanced algorithms automate design processes, balancing competing constraints to ensure that upgrades and extensions will function effectively. And in urban areas with a crowded underground environment, the designer can easily manage those spatial complexities to avoid conflicts. Treatment plants are vital for ensuring that the water we drink is safe and the water we discharge won't pollute the environment. Collaboration is critical for engineering these complex facilities, as professionals in different disciplines need to ensure that all aspects of the plant work correctly together. The treatment components themselves, the supporting mechanical and electrical systems, the building that houses all of it, and even the surrounding site. By ensuring that each engineer has the latest information from every other engineer, the whole team can avoid surprises and deliver projects more efficiently. And of course, construction is where those designs become reality. Engineers, contractors, and suppliers can collaborate to do dry runs of construction, looking at everything from the staging of materials to the placement and movement of equipment. Bentley provides the software to operate all aspects of the water infrastructure. We're proud of our role, empowering infrastructure professionals to design, build, and operate the world's water infrastructure through the adoption of intelligent digital twin solutions. And we're even more proud of the work our users do with our tools every day to advance the quality of life for so many people around the world.